Hey guys, this is another video for Group 1 students working on Apex. So I have had a couple questions about what do we need to be taking a picture of? Like what work are we actually taking a picture of? And the work that I'm talking about, the first thing is this 5.1.2 checkup, the practice problems. And you get them by clicking this orange briefcase with a little check mark on it. Then you go, it'll pop up another window. I've already clicked on it, so that's why I've got this. And I've zoomed in on two specific problems, the graphing problems. And with these, you're supposed to graph two lines and see where they cross, which is not so tough usually when you've got, graph paper and pencil. If you've got that, that's my recommendation. You should know how to graph them. I'm not going to go over these ones specifically just because, they're the homework problems, and I'd like you to think about those. But let's take a look at some others that I found online. Now here is a good example of ones that are not even set up for slope-intercept form. So we have to get y by itself. So this top one, they did the work here. It's kind of hard to follow what the work is, but they added 3y to both sides. That's how the 3y got to the right. And they added 2 to both sides. That's how the -2 became a +2 on the left. Okay. Then they have to get y by itself, so they divided everything by 3. That's why these are written as 2/3. Anyway, now this is in slope-intercept form, where it's y, except that the y is on the right side, but it's y equals 2/3 x plus 2/3. That one's kind of a messy one, but you would start at 2/3 and have a slope of 2/3. Anyway, this one's a little more straightforward, where you would subtract 4x from both sides, and then you'd have a -4x on the right side. You'd start at 24 with a slope of -4 over 1, so down 4, right 1. All right, so graphing these, now especially this one would be kind of tough. I guess when I didn't really think about it at first, but this is a tough y-intercept to graph by hand. But what I'm going to show you is another way how you could display it for me. So, like I said, I'd like you to do this on paper and pencil, but I know these two problems in particular are going to be tough. So whenever we have graphing problems, I am okay if we use the Desmos.com graphing calculator. Okay, and you can type in the equations, and as long as you type it in correctly, you will get a graph. You still will need to answer the question based on what it's asking. So in this case, what was that one equation? Y equals 2/3 x plus 2/3. Okay. Now that one would normally be pretty tough to graph, but you can see on a graphing calculator, it's really not so bad. You can see the y-intercept is 0.667. That's the decimal approximation of 2/3. And if you look carefully, like here's a point where it's going through a nice point, and if you go up, the slope is 2/3. So if you go up 2 from here, 1, 2, and then right 3, 1, 2, 3, you can see that it crosses at another nice intersection point. Okay, up 2, yeah, 1, 2, 1, 2, 3, right there. Okay. Anyway, the other one was y equals -4x plus 24. Okay. So that one is kind of off to the side. We can zoom out a little bit to see where it crosses at the y-intercept, 24, and then it does have that -4 slope. So that means from here you're going down 4. So and these are going by 2's right now. So this is 1, 2, 3, 4, and over 1. Okay, so you can see that. And it goes down 4 over 1, down 4 over 1, and they do intersect. Okay, so in this situation, the system of equations, the solution is where they cross, and you can see that's 5, 4. And the nice thing about Desmos is you can just click right there, and hey, there's 5, 4. So that is the solution to this system. You also can get parallel lines or lines that overlap each other. Remember parallel lines. Here, I'll make up another situation. Let's get rid of that one. Say you have another equation, y equals -4x minus 5. Key thing is I made it have the same slope at different y-intercepts. That means these lines are parallel, right? If you have the same slope, they're parallel. And if they have different y-intercepts, then they're different lines. And you can see I could zoom out farther and farther and farther. These lines are never going to cross, okay? I mean, I can keep zooming out until you can't really tell the difference between the lines, like right there. But technically, you know, they're not ever going to touch, okay? So that's one situation. Or here's another one. Let's see if I can do this. 4x plus y equals -5, okay? So it might look like nothing different happened, but this one's in purple, this one's in green. So here, let me make it a little thicker. These are two different looking lines or equations, but when you, here, if I unhighlight the purple, it turns to green. And that's because these are the exact same line, right? When you graph them, they overlap each other. So I guess it's actually a little darker purple. So if I unselect the green, it becomes more like black, I suppose. So anyway, they're overlapping each other, meaning they're the exact same line. In this case, they would have infinitely many solutions. Okay, anyway, let's go back to those first two original. I would want you to show me this image. You know, I want you to display it. There's this option up here that says share graph, okay? So you might want to zoom in a little so I can see where they're crossing, and I can see the X and Y axes. There's other things you can do to make it, get more details on the graph. Like right here, I could put arrows. So now I see the arrows on all the spots. Sometimes I do this. I can label it X on the X-axis. So you can now see a little X popped up. I can put a Y on the Y-axis. Now that popped up over here. So there's some little details there. Not super required, but the biggest thing is I need to see where the lines are and where they intersect, okay? It'd be really great to also be able to see the X-axis and the Y-axis. One thing that maybe, I have to zoom out pretty far to be able to see the Y-intercept. So if you wanted to, you'd have to zoom out maybe like there, you know, so now we can actually see the Y-intercept. That might be nice. Okay, so go to this share graph, click there, go to export image, and then you get this little, screenshot kind of the graph. And there's different options. You can do medium square, small square. I don't like small square as much because it doesn't give you any of the detail. Medium square is probably one of the best sizes. You can make the lines thicker so it's easier to see, or medium. I usually like medium square, medium, but there's other options as well. These ones, I really honestly don't know what those are for. Maybe it's programming or something, but you can also do large rectangle, medium rectangle. It all depends on what you're trying to show. Anyway, medium square, medium is usually one of the better ones. You can download the image as a PNG file, or what I usually do is I right click, or on a Chromebook, I think you can just use 2 fingers and copy the image. I have a Google Doc already open, and I can Control V, and there we go. And then I can adjust the size. You know, there's one graph, and like, okay, maybe I wanted to do also, these bottom two, but remember they're the exact same line. But I can export this image, medium square, medium thickness, looks good. Copy it, and I'll paste it there. And maybe I want both to fit on the same graph. Yeah, I don't know what I mean. At this point, I like, I kind of get particular, I guess, a little bit. I like them to be about the same size. Another thing you do is format them, put like borders around it. Make it kind of thin, kind of make them stand out a little nicer. If you're doing the graphing like this, I would like you to then still include some commentary. What I mean by that is some notes explaining the image. That would be better. So maybe a better way to display it would be to use a table. I see I've got 2 graphs. If I want to put commentary underneath each graph, I could do a table. It'll be a 2x1 table. I can click and drag this in there. And then this commentary, the solution to the system is 5,4. Since that is where the 2 lines intersect, cut with Control X there. And I'm going to paste it, Control V. Now I have the commentary directly with my graph. And this one, put here, and I could say, there are infinitely many solutions to this system because the two equations give the exact same line. So the lines intersect infinitely many times, something like that. Would be make it a little nicer, I think. And like I said before, you could then include an image of your work or maybe a couple images. It would be nice to see it all in one document. Again, if you do more than one document, that'd be fine as well. But yeah, do what you can to make it look kind of nice, easy to read. That's always good for the teacher to see, and it's a nice practice for you. All right, let me know what questions you have.